Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from SGI. We have Bill Mannel. He's the General Manager of Compute at the company. So, Bill, welcome back to the show.
Oh, thanks a lot, Rich. It's great to be back.
You bet. You know, Intel's been busy these days with announcements, but I see you have some new things to tell us about with their new E5 Xeon processors. So why don't we launch into that, and we'll do a Q&A at the end.
Oh, that'd be great. Let's start out in slide 2. So what we're going to be talking about is the new performance and features that we get through some of our core platforms with the new Intel processor, codenamed Ivy Bridge, but official name is the Intel Xeon E5-2600v2. I'll also talk about a couple notable and relevant customer wins that are actually working today with this new processor. So it's very exciting stuff. Going to slide 3, the first platform that's being upgraded is the Ice X. And so this is our high-end supercomputer. It's specifically optimized for HPC. So customers buy it for doing some of the toughest jobs in the industry. It is a platform that scales out to many racks. Most customers start at a couple racks, but we have some customers that are in the 10, 40, 50, 100 rack or so. Now, with the new processor in there, we get a peak performance capability 40% higher than the previous generation, often called Sandy Bridge, but official name is the E5-2600. Now, with this earlier technology, we were able to implement the largest supercomputer in the commercial space. So by commercial, I mean not funded by essentially public money. And that's at the oil company Total in France. And it's a peak 2.33 petaflop system, all implemented in Ice X. And we'll talk a little bit about that system more later. Now, one of the great things about our Ice X platform is the fact that it achieves leading efficiency. So it turns all those peak petaflops into real work. So for a lot of applications, we get up to 90% or higher peak efficiency out of the Intel chips. So what we're looking at here is a great amount of new power for customers going forward. Now, the Ice X is a standards-based computer, so it's based on x86, InfiniBand, and also vanilla Red Hat and SUSE. So there's no proprietary interconnect, no proprietary operating systems here. It's all standards-based, which makes application running and porting very easy for a lot of our customers. Now, if you go to slide 4, we're in the process of running a benchmark. I wish I had it here for you today, but we've had some off and on file system problems with our machine, and we do hope to have that available on launch day next week. But in every previous generation, when we've upgraded the system or processors for Ice or for Ice X, we've actually achieved the highest result for the MPIL benchmark, which specifically tests MPI level performance on a large scale-out type system. So we'll be testing out the 4600 ranks. That's basically 4600 cores. So again, a sweet spot for this particular machine. And stay tuned for that benchmark. Again, we're hoping to get it by next Tuesday. We might get a little after that as well. Now, if you go to slide 5, Ice X, this is our latest platform. We launched it about a year and a half ago. I have a lot of great customer wins so far. The great thing about the platform is that it has a variety of different cooling type of architectures. And one of the more interesting ones is what we call the M cell. So it's a completely self-contained unit that allows you to take a lot of the infrastructure in a lot of data centers out of the equation. So we can actually utilize warm water up to 32 degrees C from a cooling perspective, and actually utilizes an on-processor cold sink. So it takes a lot of that heat out of the hottest elements of the machine itself. Now, other elements such as DIMMs and the host bus adapters for InfiniBand, they're actually air-cooled as a part of the system. But the hottest parts are actually liquid-cooled. The other great thing about Ice X is it does support multiple InfiniBand topologies. So a customer can customize their particular Ice X based upon the particular workload they have. If you look at the next slide, slide 6, you'll see some of the InfiniBand topologies that we support. So an all-to-all topology, a fat tree topology, which is quite popular in the industry, a hypercube, and also enhanced hypercube. And in fact, we can achieve nearly similar, in some cases similar or even better performance using a hypercube or enhanced hypercube topology versus a fat tree. A fat tree needs a lot of additional external switches to enable it, especially in a large system, and we can do this or get similar type of performance in a hypercube or enhanced hypercube without the expense of all those additional switches. So in summary, our first platform that's going to run the new Intel processor is the ICE-X. I have a great customer quote here from Total. This is, again, our largest system in the commercial space, and actually the largest supercomputer in the commercial space in general. And there's a great video that you can watch at that link below. That the Total people themselves actually created a great video about our platform, which is a great thing when your customers create your videos, your marketing videos for you. So let's segue now to the next platform that's getting an upgrade. That's our rackable platform. So these are 1U, 2U type rack mount platforms. They fit into standard type 19-inch racks. Where we provide value here is around the solution that we provide with them from a software, a consulting, and a services standpoint. We also test at the system level, so we put a whole system together for a customer in the factory. We test it out. We take out any components that fail right away and replace them. And then we test it again until it finally passes all the tests for a certain period of burn-in time. Then we wrap some box around it, put it on a pallet, and ship it to the customer. So when it arrives on their floor, you can plug it in and have fairly rapid availability of that system to their programmers or their developers. This is in contrast to a lot of vendors out there that ship in all the hardware and then send in a couple people to assemble it on the customer's floor. We do that in our own factory, which, by the way, is right next door to our main engineering team for servers, and so it really helps to get the best quality product out the door. So we have a number of solutions that are based around our rackable platform. One of them is HPC clusters, which we can do either with Gigi or InfiniBand. Another is clusters for Hadoop, so we have quite a Hadoop-based business. And then finally, we have a data wrap, what we call Data Raptor, which is a NoSQL appliance that we provide for customers. So all these build upon standards-based rack mount servers that we provide to customers. Now, the great thing about Rackable is we were able to complete the benchmarks. So we actually set a couple records. The MPIM, which specifically tests MPI-based performance, we set a world record for, and also SpecOMP as well. So a couple benchmarks that we were able to work with our benchmarking team and get those working. We do have a TerraSort benchmark that's in production. We'll be making that available soon, and we hope that will be a great benchmark as well. And then our final platform that has had an Ivy Bridge upgrade is our modular infant storage platform. So this is a new platform. I think actually Floyd and I talked to you, Rich, about this platform back in the springtime.
Yeah.
And it's basically a very flexible platform. It can be used at a variety of things. It's very dense and a very capable system as well. So if we go to the next slide, slide 11, we can put 324 raw terabytes in a 4U, but we maintain that nice 19-inch form factor, so no special form factor here. We offer flexible deployment, so you can have a storage server or just a JBOD, and you can mix and match a variety of different technologies, whether it's SAS, SATA, or SSDs in the same box. It's set up around high throughput and also lots of redundant capability as well. So redundant components, multiple RAID options, and a variety of hot swap components as well in the platform. On the next slide, slide 12, probably the most relevant here is the server flavor of it, because it's the one that actually has up to 2 Intel-based motherboards. It's been running the Sandy Bridge processors, but now with the new E5-2600v2, we'll be shipping those new processors out so that customers can enjoy the capability of those processors as well. So let's talk about the customer win. So we've talked about the 3 platforms we're upgrading, the IceX, the Rackable, and the Modular Infinite Storage platform. The great news is we already have some great installations and some great customer stories. One of them is at NASA, and you're probably familiar with the NASA Pleiades system. This is a system that we've been developing with NASA and Intel over the past few years or so. It literally started at 8 racks, and it's progressively grown through multiple Intel technologies, starting with Harpertown and going through Nehalem and Westmere and Sandy Bridge, and now it's up to Ivy Bridge. And it's gone through a variety of different InfiniBand capabilities as well. And the current system, I don't know exactly the number of racks, is probably up in nearly 200 racks, but it's actually our biggest system right now. It's a 2.88 peak petaflop system with this latest edition. We put it in 45 racks. We installed them in chunks over a 1-month period, and they're all up in operations today. And one of the first applications that NASA is working on them is a project they have for discovering new planets. And they've already discovered 136 new planets out there in the heavens. So great customer success story, both being able to bring the platform up quickly and being able to expand the platform over multiple generations. So here we haven't had to clean the floor of all the older stuff. We actually expand from that standpoint, adding more capability at lower cost and less interruption. And on the next slide, slide 14, great quote from NASA there, the division chief, Rupak at NASA Ames, saying that with our architecture, they're able to grow their system and they can keep working. Not avoiding lots and lots of downtime from the standpoint of all their clientele, which is thousands of scientists at NASA and around the world who are doing research on the Pleiades platform. Another great customer we have is on the next slide, slide 15, at iCheck. iCheck is the Irish Center for High-End Computing, so it provides compute capability for Ireland from both a public and a private sector standpoint. We just shipped in 10 racks of SGI hardware, and they just commissioned them within the last couple of days or so. Lots of cores of the new Ivy Bridge processor in an IceX, as well as a large shared memory system. So they also purchased a UV2 platform, as well as some accelerators as well. So a great mixed use type environment that can service a lot of different types of applications. If we go to the next slide, slide 16, these are, again, another happy customer. We basically got the system up and running in a couple weeks. They're already doing application and testing and porting. With the new SGI systems, they're able to do more science, bigger models. Among the things they do are weather and climate research. They also do research into materials. And also into bioinformatics as well. So a great number of different interesting applications available through this particular system. So next slide. So in summary, Rich, we have three new platforms with the Intel E5-2600v2 processor, or commonly known as the Ivy Bridge processor. Again, our IceX platform, our high-end optimized server for high-performance computing, our Rackable platform for solutions-based computing, whether it's Hadoop, HPC clusters, or NoSQL, and then finally our Modular Infinite Storage product for large scale-out storage type environments as well. So that concludes what's new at SGI and what's coming out with the great Intel announcement next week.
Well, thanks for that, Bill. A question right from the beginning there. You mentioned this 40% performance increase that's possible generation to generation. What is, we're recording this before Ivy Bridge for servers has been announced. What is it about that processor that enables that? Is it bigger caches, or what's it got going?
It's more cores.
Yeah.
So it's simply a function of adding more cores. Depending upon which particular SKU you're looking at from a Sandy Bridge perspective. There's an Ivy Bridge version of it with 50% more cores.
Mm-hmm.
You can quickly get to, from a peak perspective, those numbers based upon adding more cores in the same space.
Yeah.
So again, Ivy Bridge Intel has a tick-tock type of process. The talk, which was Sandy Bridge, is a major microarchitecture change. So they've introduced new features and capabilities in the chip. But a tick, which is what Ivy Bridge is taking that and shrinking it. And typically, when you shrink it, you create more space on the chip so they can add more cores. And so that's the core of our performance increase here.
Yeah, terrific. So on the ICE-X platform, Bill, it looks like a big monolithic kind of setup. When you build it, is one unit of the ICE-X, is that equivalent to 4 racks, or is it more than that?
We can, to be honest, we can actually start at a half a rack.
Oh, okay.
So we can start at a half a rack and grow upward. Typically, a lot of our customers tend to start at about 2 racks, and in some cases even 4 or 8 racks from that standpoint. Now, even though we've got really big systems, we actually have the ability to manage them starting at the enclosure level. And so you can actually, starting at the individual blade level, believe it or not. So individual blade level, then the enclosure level, then the rack level, then the entire system from that standpoint. So one of the beauties of the platform is our management layer, which even though the system has grown so big, it still feels small to the system administrator.
Yeah. And then for your storage offering, what does Ivy Bridge bring to the table there? Is it with more cores, more bandwidth, or what do you think?
So a variety of things. Certainly more cores are available. Ivy Bridge has a faster memory capability and also a greater power efficiency than the previous Sandy Bridge generation as well.
Yeah. Well, Bill, this sounds terrific. SGI is always right there when Intel comes out with a new generation, and it looks like that's the case here. So congratulations on that. And I want to thank you once again for coming on the show today.
All right, thanks a lot, Rich. As always, a pleasure.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.